Right, for the very first part of this video, I'm going to be showing Terraform. And Terraform is going to be used for automating the architecture and creating all the AWS resources we needed. Before we actually run any scripts, I want to open here my console in AWS, and I'm going to show what I have open. So on the VPCs, I have a ticket system VPC and I have the default VPC. Neither of these are going to be used for the actual architecture. Ticket system VPC is just where my setup virtual machine currently lives on. For the subnets, we have 6 subnets. There is 3 subnets here which are default and 3 which I created. Again, these are used just for the setup virtual machine. There's 2 gateways, default one and one for the setup virtual machine. On instances, I have 2 instances. Setup VM, this is the one where we'll be running the Terraform and Ansible scripts from. And the other one is first VM, which I used for doing the QA tutorials. This will not be required for this video. On security groups, we have 2 default and 2 that I created. Key pairs, I have these 2. I have no running RDS instances, and I have a default subnet group. That's what I have. So let's first log into our EC2, which for the virtual machine is this one, setup VM. You can see there EC2 35.176.102.251, which is here. Now, once I SSH into it, I am going to go on to my ticket system DevOps. This is my repo. And inside that, I go to the Terraform folder. And all I have to do is run Terraform apply. And that will begin creating all the resources we needed for this project. Now, while that's creating, I'm going to be going into the actual architecture and talking about it for a little bit. If you go onto the repository, Gafar ticket system DevOps, on the README, you'll see final architecture. So I've opened the final architecture. Let's talk about which stage we're at right now. What's happening with the Terraform right now is we logged into the setup virtual machine and we run the Terraform apply. What the Terraform apply is going to do is it's going to create an it's going to create a VPC. Within that VPC, it will create a root table. It will create the internet gateway, and it will create an EC2 instance. At the moment, this EC2 instance that's going to be created will be blank, but it will further down the line will be used for Jenkins. It will create a key pair as well that will be used for SSHing from the setup VM onto the Jenkins EC2, and this is based on ID pub. And other than that, it will also create an RDS subnet group, 2 subnets within that RDS subnet group, and a MySQL RDS instance. Within that MySQL RDS instance, it will have the RDS security group, which allows port 3306 to be exposed. Now, both of these are public, so that this is publicly accessible. And same with the Jenkins EC2. It's going to be publicly accessible, and the Jenkins security group allows it to be exposed for port 8080 as well as the SSH port. Now, let's see how things are going. This will take a while, so I'm going to continue this video as soon as this is finished. Right, as you can see, the script has now finished and it says 17 resources have been created and have been applied correctly. These are the outputs that have been given out, and I'm going to make a note of these outputs because they will be used further down the line. So I'm just going to open a notepad and paste them in. You will notice within the outputs it has the ID for the Jenkins EC2, the IP address for the Jenkins EC2, RDS endpoint, a generated password which is generated differently each time, and a user, as well as the VPC ID. Now let's go back onto our Amazon console and check that everything has been created as expected. So previously there was 2 VPCs. Now we have 3. This is ticket system VPC here. is the latest one that has been created with the CIDR 11.0.0.0.16. And if we look back onto what we have pasted, the VPC ID here, 011B3BF30, well, that number corresponds to this one. Okay, so we have the VPC created. Within the subnets, we previously had 6. Now we have 9. Here we go. So we got RDS subnet 2 and RDS subnet 1. These two are the ones used for the RDS, and then it also creates this one, which I forgot to name. But nevertheless, this one is the one used for the EC2 instance. All of these are publicly accessible. And let's continue. The gateway for the VPC is here as well, ticket system IGW. So before there was 2, now there's 3. Instances, we previously had 2 instances. Let's open that again. Right, we have 3 instances now. This is the Jenkins EC2 instance, which is created by Terraform. Security groups, let's go. All right, we've got 7 security groups now. The security groups that have been added are these: Jenkins EC2 SG, RDS instance SG. These are the ones that this is the ones that's going to be related to Jenkins, whereas this one is going to be the one related to the RDS. Key pairs. We have 3 key pairs. This is the Jenkins EC2 key. This is the one that we're going to be using for connecting the setup virtual machine to the EC2 instance, where we're going to be configuring Jenkins via Ansible. Onto the RDS, let's have a look. Before there was nothing. Now we have RDS ticket system, which is a MySQL database. And finally, the subnet groups. Before there was only the default VPC subnet group. There should be an extra one now. Here we go, RDS subnet group managed by Terraform. So now that we've shown that Terraform can create all of those, it's time to show the Ansible side of things. So I'm gonna change from Terraform onto Ansible, and within Ansible I have a folder, Jenkins EC2. So the playbook here is specifically related to this Jenkins machine. It will install everything we needed from Jenkins, which will include the Java installation, Git, because Jenkins needs Git installed separately, I'm not sure why, and Docker, because Docker is what we're going to be using for creating and building the images. Now, before we run, the inventory.yaml currently has inventory.yaml currently has just an EC2 IP placeholder, which has been done that way so that nothing has been exposed. So let's go back to the output we had copied from Terraform, which gives the Jenkins EC2 public IP, and let's paste this in. Now, once we've pasted that in, we can now run the playbook to configure this machine. I will continue this video once it is finished. Right, as you can see now, the Ansible script has finished, and one of the things you will notice is that it will print out a step called Jenkins print init password Jenkins. Within that step, we get this password, and this is the initial password used for Jenkins, so let's make a note of that. Now, Jenkins, so this is the IP address of the EC2 instance, which we're going to be using. And let's open up a new window on Firefox, and let's open port 8080. Jenkins by default goes straight onto port 8080. We've got the password there. Let's use that password to open things, and let's just install the suggested plugins. This should be quite quick, around 2 minutes. While that's working, I'm also going to open my Docker Hub account. Okay, so these are the two projects the Spring Boot, this is the back end, and Ticket System is the front end. On the back end, you can see that the last push has been done 16 hours ago, and the last pull has also been done 16 hours ago. Similarly, for the front end, it's been 20 hours and a day ago. Okay, this has been finished. Let's create a user. Okay, it already picked up the Jenkins URL. Start using Jenkins. Now, once we have Jenkins set up, the very first thing we need to do is we have to manage credentials, and we need to add some credentials. The credential I'm going to be adding is for my Docker account. Similar to the way we had the Docker Hub credentials added, we also have to add credentials for GitHub. And after having the credentials, the final thing we need before creating our build is some plugins. Let's go to the available plugins and look for Docker. We want Docker, Docker Pipeline, and Cloud-Beast Docker. This is the one that's going to be pushing the images to the repo in the Docker registry. Let's do an install without restart. Okay, now that they've all been done, let's go back and let's create a job. I want to specify front end as one of the pipelines. GitHub project, do not allow concurrent builds. Now I need the project URL. The project URL for the front end is this. So this is just on my repo Gafar ticket system front end. Build triggers, I want to set up a GitHub hook, and on the pipeline I want to get it set up as Git, and let's get the Git credentials, and the branch is main. Right, let's save that, and let's kick off a build. Now, while that first build has kicked off, I'm also going to go back and create a pipeline for the backend. And similarly, I'm going to set it up in the same way as I had done the front end, this time with using the ticket system backend repo instead. Now for this one, gotta be a bit careful because the script path for Jenkins is slightly different. Instead of having it as just Jenkins file, I need it as a Spring Boot server Jenkins file because of the way the project has been set up. And again, let's kick off a build. Let's go back to dashboard. Why did it fail? Couldn't find refs heads main. Okay, that's bad setup by me. Should be single N. Let's try that again. The front end build is still going on if we look at the console output. So at this point it's stepping into the Docker file. We can see the steps being run. And let's see. So last push is still a day ago. This might take a bit of time. Let's look back onto the back end one. Again, so it's gotten into the Docker file and we can see the Maven dependencies being downloaded at the moment. We will run the Maven dependencies and run the unit tests and everything. I will continue this video as soon as these two have finished. Actually, no, that looks like it's finished. So the front end is now blue and says success. Let's have a look at that. So it was previously a day ago, was last pushed. Here we go. So the latest image has now been pushed a few seconds ago. 3:58 p.m. It's 3:58 p.m. Perfect. So we've got the pipeline working for that. Right, it's been a couple of minutes now, and build duration is also finished for the backend. Let's refresh the backend. So backend is this one, Gafar Spring Boot on Docker Hub. Previously was last pushed 16 hours ago. Let's see about this now. And here we go, last pushed 2 minutes ago, 3:59 p.m. It's 4:01 p.m., which is perfect. We now have the Jenkins working completely. Now the other bit we need to do was to create the webhooks. So let's go to this is the ticket system front end. And in here, I'm going to go to settings, webhooks, and add a webhook. The webhook I need to add a URL for Jenkins. And then I need to write GitHub webhook / Okay, so we've added the webhook for the front end. Let's do the same now with the back end. We can see that the last delivery has been successful. Right, this is an old webhook I had for a previous Jenkins server. Let's create a new one for the new Jenkins server we've just created. Again with the JSON. Here we go, let's see how that's going to work. Here we go, we now have both of the webhooks active. Now we need to check that the webhooks are actually doing something. So let's go to the project and I'm just going to edit the README file. So I'm just going to remove these lines here. And on the commit changes, I'm going to have it as a demo webhook. Let's commit those changes. Okay, so that should have automatically triggered a build in Jenkins. Let's see if it has. Oh, it looks like it has. Let's go to backend. Here we go. We've got the full pipeline working now. And if we go on to changes, there we go, demo webhook. With Jenkins and Terraform and Ansible out of the way, what we have is, let's open the image again. So we have this bit completely configured. We have this whole VPC ready to go. What we still don't have is this bit here, which is the Kubernetes cluster. And this is what we're going to be using for to have the clients connect to the application. So let's move on to the final step, which if we go on to the repository, so not repository, sorry, ticket system DevOps, on the setup virtual machine, there is a file called Kubernetes. In that file called Kubernetes, there's the YAML files used for the Ingress controller for the front end and back end. Now, what we want to do is we want to run the bash script. The bash script will actually run all of them, and the bash script was done to hide away some of the details to avoid us exposing it. So the first thing it asks is for the RDS URL in the form of the endpoint and the port. Now, recall that after we had run the Terraform and it had created the RDS, it did spit out this RDS underscore endpoint. So let's copy that. We'll also ask for the username and the password that was auto-generated, which is this. Okay, so once I click enter, what's going to happen is the EKS cluster is going to be generated, and so the EKS cluster will be generated. The network load balancer is going to be created. The ingress rules are going to be created so that traffic with /API are routed onto the backend service. Within the backend service, there's the backend pods. And these backend pods are connected via a JDBC connection to the MySQL RDS instance, which we just gave the details to. For the front end service, just a normal URL without anything following it will connect straight to it. So now we're just going to have to wait for this to install, and hopefully everything should be perfectly fine. This can take quite a bit of time, so I will continue the video once this is ready. Alright, I'm back, and the script has run, and it has created the clusters, it has run through the YAML files, and what we can do now is go to EC2 and confirm that it has been created. Here we go. So now we've got the clusters in, and we'll notice as well on the final thing that's printed out once the script is run is the ingress address, and this is what we have. So let's copy that, and hopefully if everything has gone right, it should be fine. Okay, there we go. We're into the ticket system. This is the front end. And how the app actually works is, let's give it a, say, demo title, demo description, and demo author. So this is what it allows when creating a ticket. It asks for a title, description, author, and then out of that you also have departments to select from, and issues, so topics. Let's just say department FX, and we're having remote connectivity issues. Let's create it. As soon as we create it, we have the ticket here. Now we have the whole CRUD functionality, so not only can we create it, we can also update it. So let's say demo title updated, demo description updated, something like that. And let's change it to credit. Okay, so here we go. Demo title updated, demo description updated, and department has been changed to credit. We can also now, if you notice as well, it has not only a created timestamp, but it also has a last time updated timestamp. And we can also delete. So this is part of the basic CRUD functionality. Okay, so that's all fine. Let's recreate another one to show some further work that has been done. Let's create one more. So this is department FX with topic remote connectivity. Let's create a separate department. Let's call it equities. Let's say messaging, for example. Okay, so we have the 2 tickets now, and let's create one more with topic messaging, but a different department. So topic messaging and retail. Let's say that. Title 3. So now I want to show the extra features I had worked on. The features I've worked on, one of them has been to add a status to the ticket. Notice how the ticket has the title description, and up here there's a third button called Start Work. Now, Start Work can be for one of the technicians. If they just click Start Work, okay, so this is now marked as like working. So there's 3 enum types of where that have been defined in the backend for where the ticket could be in. It could be where the work is not started, where it's in progress, and once it's marked as done. So once you mark it as done, you get an extra field that comes up, and this here is the demo solution. Now at this point, everything else has been not allowed to change, because we want to preserve the original ticket, and we can mark it as done. Now, once it marks as done, you cannot update, delete, or done, because we want to preserve history. And notice, for example, this one here just has title description, whereas this one here has title, description, and solution now. Now the other 2 features that I had was so we've had the option of picking the departments and topics, but then we want to be able to filter out by which one of them we use. So say we want to filter by department. In this case, let's pick department's credit. Sorry, department's FX. Here we go. This is the only ticket in FX. Let's see what. So if you go to all departments, we have a ticket FX, equities, and retail. Equities will show that, and retail will show the final one. Now, we could also do the same thing by filtering out by topics. So we have one topic which is remote connectivity, 2 of them in messaging. Let's say if we go by remote connectivity, it will show this ticket only. If you go by messaging, it will show the other 2. And if you want to go back to all topics, it will show everything, and we're happy to remove them. So this is the full functionality of the application so far. Right, I've shown the full functionality of the app. Now I want to show a more meaningful change for the continuous deployment. Let's say, for example, here in the banner, we have ticket system. Let's open the repository. And let's go to ticket system front end. And let's go to banner component. Now here we had the ticket system, right, which is written the way it's been written before. I'm going to change it all to capitals. So let's edit this file. And let's commit it as CI/CD demo. Okay, we've done that. Let's have a look at the Jenkins server now. Okay, so the build has been automatically triggered as expected. Okay, that's almost finished. Okay, it's been pushed now. Let's have a look. Okay, pushed a few seconds ago. So we've used the CI/CD to show the ticket system being changed. So now let's see if we could redeploy the front-end pods. Let's delete them and let's reapply them. Okay, so we have reapplied the front-end pods, and let's go back to our React app. And here we go, all capitals, showing the full CI/CD pipeline working. I'd also like to show the development environment so that I could show the unit test, automation testing, as well as testing coverage. I'm going to be showing it using Eclipse. First thing we need to do is import and Maven, existing Maven projects. Now the root directory we have to select is, in my case, it's going to be ticket system backend, which is it provides two POM files because there's two testings. One of them is Spring Boot server, the other one is automation testing. This is where Selenium lives. Now when we add them both, here we go, we've got both of them added in. For some reason that picked up the wrong JRE library. It's supposed to be Java 11. Let me just change that quickly. Right, so the tests are completely dependent on Java 11. So once I change that, hopefully that warning sign should be gone. Yep, the warning sign is gone now. Okay, so first thing I want to show is this is the ticket system project. What I'm going to do is I'm going to run coverage as JUnit test. You'll notice that there is a 52 unit tests which cover multiple things, including unit testing, integration testing, and they cover the services, the controllers, the repositories, and anything I've ended up using. And this should give a total of, here we go, so that's completed. That says 99.1%, but that's right, here we go. So on the source main Java file, there's 96.4% coverage with 933 covered instructions out of 968. I have also added this onto the ticket system backend repository where you can see the code coverage as well as the breakdown by each individual part. Similarly, I could also show the same for the front-end project. So this is the front-end project that I have imported into Visual Studio Code. Now to run the coverage here, I just have to run npm test a -- coverage on ticket system front-end folder. Let's have a look. This one does not have quite as many tests as the other one. It has a total of 12 tests. However, the test coverage is again really good. Within the source folder, it covers 100% of branches. Source components 96.67. So again, we have like very high unit test coverage. The final thing I wanted to show is not just the unit tests running, but also the Selenium automation testing. So what I'm going to do is I'm going to start a development server because I do not want to mess around with the prod right now. And my automation on the back end, I'm also going to run a local server. Okay, so we have the dev server running. And the final thing now is just to show the automation test running, which uses a Google Chrome driver. So let's just run as JUnit test. And it runs the crude test first, a filtering test for the extra features we have added, and a solutions test as well. And there we go, that's the end of it. Please note that I have 3 repositories for this project: ticket system backend, ticket system frontend, and ticket system DevOps. I will add you guys, Nick, Luke, and Reese as contributors to all 3 of them. Within these repositories, the backend one will contain detailed instructions where you can even generate a Sonar report if that's something that you want. The project is configured for Sonar build. There is ER diagrams, risk assessment, and sequence diagram, as well as the link to the Jira board. And if you would like to contact me by email, you could also just click on this link and it will take you straight to the email. The coverage is there as well as the developer requirements. On the front end repository, on the README, I also have the code coverage as well as the generated README for Node and how to run the project. And lastly, on the ticket system DevOps, you could see the final architecture diagram, which I've spoken already about in the video. The link, once you click on that, it will give you access to the Jira board. For the sequence diagram, this is the link that I've clicked before. There is multiple states that you can see, from viewing tickets, creating, updating, and all the other steps are all there. And the risk assessment is also in there. Please have a look and read through it. And there's also the ERD diagram, including what it was for the MVP as well as the final product, which includes the relationship with topics and departments. Thanks for everything, guys. Goodbye.